Hello friends, we want to start this topic called survival equation. This equation is responsible for finding the number of particles that can move from one point to another without having collision or dissolution. Why I am talking about collision? Because this collision to the fine particles will lead to the destruction of these particles. So we want to calculate the number of particles that would survive this distance and reach over here. So this equation is called survival equation. So let us consider N0 amount of molecules at the start. So after time t, this N0 molecules reduces to N after traveling distance, suppose x. So therefore dn can also travel dx distance in time dt. Okay. So this leads to the understanding that the dn is proportional to dx proportional to pc, the collision frequency proportional to the number of particles that are considered into this particular system. So we write dn is equals to n pc dn n pc dx. So we bring this dn over here and pc dx here. So on integration, like for n equal to n0 n, and for x to x, so we write this ln n by n0 is equals to, and there should be one negative sign over here. This negative sign possibly indicates that this fraction dn is reducing the population to its bottom. So we can write minus pc x, so n equals to n0 e to the power minus pcx. So we come across now two important terms has to be defined. One is free path, another is mean free path. Free path is the length of the distance that a particle travels from point A to point B without collision is called free path. And mean free path is the mean of all the paths. For example, if we take molecule 1 travels distance x1 as free path, molecule 2 takes distance x2 as free path. So if you take the mean of all this, then it arrives to mean free path. So numerically this definition can be written as integration x dn x dn by dn. Now these two equations are important that are written over here. So this mean field path in physics, it is denoted by the Greek letter lambda. So you can write lambda is equals to x into this dn expression has to be written with the modulus sign. That means we take the modulus of this, so it becomes n pc dx, where x runs from 0 to infinity and this n is nothing but just simply n0. If you integrate this dn, this is simply n0, the total number of particles. When you have used this, so delete this. So now we have to use this equation. So lambda is equals to x is equals to 0 to infinity x into pc, and here you have n0 e to the power minus pc x dx, and the bottom you have it. So n0 get cancelled out, and we have lambda is equals to pc into integration 0 to infinity x e to the power minus pc x dx. So this can be written as lambda is equals to pc into 1 by pc square into gamma of 2. Gamma of 2 is just 1. So lambda is equals to 1 by pc. Therefore, the collision probability is 1 by lambda. And the equation so far we have used this one. If we use it over here, so our final survival, this equation is called the survival equation from our definition of the survival equation. So this n can be written as n equals to n0 e to the power minus x by lambda. So this is your modified survival equation. Thank you.